This is the video lesson for Introduction to Power. The essential questions for this lesson are, how do we define power in physics, and how do we calculate power in different situations? All right, so let's look at the definitions of power. So power is the rate at which work is done, or we can also think of it as the rate of change of a system's energy. So for the equation, we have P is equal to W over delta T. So power is equal to work over the change in time, or change in total energy divided by change in time. So power is equal to, again, the change in energy divided by the change in time. The units of power are equal to watts. So 1 watt is equal to 1 joule per second. And a kilowatt, which I'm sure you've heard of before, we use this a lot when we're thinking about electricity, a kilowatt. 1 kilowatt is 1,000 watts. So let's look at an example. So what is the power required to lift the 20 kilogram TV from ground level to the 4th floor, which is 12 meters, in 30 seconds? So here we have a little diagram. This person is lifting a TV up to the 3rd floor here, or the 4th floor rather. So how much work is done, or how much power does it take to lift it up there? So power is equal to work divided by time. So our work is going to be force times D times cosine theta. And our time is just the amount of time it takes. So the force is going to be the mass of the television times gravitational acceleration. So our force then is 20 kilograms times the gravitational acceleration. That's 10 meters per second squared. Our displacement is going to be this 12 meters. That's how high it goes up. So that's 12 meters. And then the direction that the displacement is in is the same as the direction that the force is in. So the force is being exerted in this direction, and the object is moving in that same direction. So cosine theta is just 1. And then we divide all that by 30 seconds. And we're going to end up with a power of 80 watts. So the amount of power it takes to move the TV up to the 4th floor is 80 watts. All right, let's talk about how power and velocity are related. So remember that average or constant velocity is equal to the displacement divided by time. So we have average velocity. Average velocity is delta x divided by delta t. Therefore, we can say that power is equal to work divided by delta t, just as we saw earlier, which means that F times delta x times cosine theta divided by delta t is equal to power. So we have force times the change in position, or the displacement, times cosine theta divided by delta t is equal to work, or is equal to power rather. So doing a little bit of manipulation, a little bit of algebra, we see that force times delta x over delta t equals cosine theta. So we've just manipulated this a little bit so that we're separating out delta x times delta t. So now we have delta x divided by delta t. We see that force times the average velocity times cosine theta is equal to power. So we've been able to link now average velocity to power. Okay, so let's look at this example. So we have a constant force, 900 newtons, pushes a 100 kilogram mass up the inclined plane shown at a uniform speed of 4 meters per second. We want to know what is the power developed by the 900 Newton force. Okay, so our equation for power is equal to force times our average velocity times cosine theta. Okay, so we have a force, which is 900 newtons. We have a speed here, so it's an average, a uniform speed, so it's the average speed of 4 meters per second. So the direction that the force is pushing in is the same direction that the object is moving up the inclined plane. So the cosine of theta, so theta in this example is 0 degrees. So cosine of theta is going to be 1. So cosine of 0 is equal to 1. So plugging everything into our equation, we have P is equal to 900 newtons times 4 meters per second, which will give us 3,600 watts. So the power developed by the 900 Newton force is 3,600 watts to move the block up the ramp at 4 meters per second. Okay, let's look at this final example. So we have a 10 kilogram block is attached to a light cord that is wrapped around the pulley of an electric motor as shown at left. At what rate is the motor doing work when it is pulling the block upward with an instantaneous speed of 3 meters per second and an upward acceleration of 2 meters per second squared? So at what rate is the motor doing work? So this is a power question. So we're going to use our equation. P is equal to F times the average velocity times cosine theta. So we know it's a power question because it's asking what rate the motor is doing work. Okay, and we can't do the power equals work divided by time because we don't know how long the motor has been working. So we have to use the force times velocity average times cosine theta equation. Okay, so to figure out the work being done, we need to figure out the power being done exerted. We need to figure out the force. So let's draw a free body diagram here. So we've got the force of gravity acting on the 10 kilogram block here. So that's 10 kilograms times g, which is 10 meters per second squared. So that gives us a force of gravity of 100 newtons. And then we have the tension force, which is pulling up on the block, which we don't know yet. So if we do the sum of forces in the y direction, we have our force of tension minus our force of gravity, and that's equal to mass times acceleration in the y direction. So our tension force minus our gravitational force, which is 100 newtons, is equal to our mass of 10 kilograms times our acceleration, which we're given in the problem, which is this 2 meters per second squared. Okay, so let's move this up here a little bit. So we have tension force then is equal to, if we move the 100 newtons to the left side or to the right side of the equation, we have 100 newtons plus 10 kilograms times 2 meters per second squared gives us another 20 newtons. So our tension force then is 120 newtons. So we've got our F. We have our velocity. Our velocity is given as 3 meters per second. So we can start to figure out what our power is. So power then is equal to F times the average velocity times cosine theta. So the motor is pulling the block up. That's the direction that the block is moving in. So theta then is equal to 0. So cosine of 0 is just equal to 1. So we have our force is 120 newtons times our average velocity, which is 3 meters per second, which gives us 360 watts, which is the power being delivered by the motor to move the block up.